Hello friends, in this video we're going to solve this electromagnetic theory paper c-13 of 6M BSc 6M Dibrugarh University. Okay, this is part 1 CBCS of 2023. So before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you. Okay, and this is my Insta ID. If you want to follow me on Insta, you can follow me OJHALAKHYAZIT 123. This is my Insta ID. Follow me on Insta. Okay, so now let's start. Now you see, first question is here: if E is the electric field intensity, then the electrostatic energy density is proportional to. Now you see, electrostatic energy density is given by 1 by 2 epsilon naught E square. Okay, so that's why it must be proportional to E square. So that's why this is the correct answer, right? So now the direction of propagation of electromagnetic wave is given by. Now you see, the electromagnetic wave, if it is propagating in this direction, so then the electric field varies. If varies in this direction, suppose in this way, right? In that case, magnetic field varies in this direction, which is perpendicular to the electric field, right? This way, right? And this is the direction of electric field, and in this direction, this is the direction of magnetic field. Then again, when electric field is downward, then magnetic field is in this direction. Both are perpendicular, and and this variation is propagating in this direction, perpendicular to both E and B. So that is why that is given by E cross B, because cross product of E and B, that will be perpendicular to both E and B, right? So that's why direction will be given by E cross B. So hope you have understood this. So this is the correct answer, option 4. Now next question. Next question 1C, Lorentz condition is, in Lorentz gas, Lorentz condition is given by. So what was the Lorentz condition? We know that Lorentz condition is nothing but divergence of A plus mu epsilon d del phi by del t is equal to 0. So this is the correct option, option number 2. And the angle of incidence is greater than Brewster's angle. The reflected angle suffers a phase change of. Now you say, when when a wave incident on a surface, if it reflects, okay, then the phase change, change in phase of this reflected ray is always pi. Okay, that's gonna be pi, right? Now you see, next question. So degree of polarization for ordinary light reflected from glass of refractive index 1.5 at angle of incidence at 45 degree. So what going to be the degree of polarization? So now you see what we need to do here. So in this case, here you see, incident angle is given theta I, that is 45 degree, and refractive index is given 1.5. So according to Snell's law, we can use sine theta I by sine theta R, that means angle of incidence by angle of refraction. So it is 1.5, right? So from here we can find sine theta R. If you find that, then what you can have, sine 45 by sine I is 45, right? So by 1.5, and sine 45 is 1 by root 2, 1 by root 2, then into 1.5. If you calculate this using calculator, or if you can calculate without using calculator, then you can do yourself. So now you see this theta r will be equal to sine inverse that's going to be equal to sine inverse of this, right? Okay, right. So now you see this value sine inverse, if you calculate this, then what you're gonna get, that's gonna be approximately 0.4713, right? Now you see, you must use calculator, or otherwise you have to find the angle using geometry. So what you need to do, first we know that sine theta is equal to perpendicular by hypotenuse. So we know that sine theta is equal to perpendicular by hypotenuse, right? So that's why what we're gonna do, we have to draw, suppose, a perpendicular on this line such that it is approximately equal to 4.713 centimeters. So in your scale you cannot draw 4.713. So take approximately 0.47 centimeter, and you have to take a point on this line such that this hypotenuse becomes equal to 1 centimeter, right? Hypotenuse become equal to 1 centimeter. You can manage that using the scale, right? Right. So then the angle formed here, you can measure the angle using the protractor, right? And that's going to be approximately 28.1. okay, that's going to be approximately equal to 28.1. So now you see what we have. Now we have theta r as well, that is 28.1. okay, so now you see, if you use the scale this way, okay, this is your scale, suppose, and this is the perpendicular of 0.47, right? You can slide the scale unless and until you get this hypotenuse equal to 1 centimeter. That's how you can do. Okay, that is the only way to find the angle without using calculator, right? Then the angle you're gonna measure here, that's gonna be this one. That's gonna be measured by, angle can be measured by using the protractor. Okay, so hope you have understood this. That's how you can do. Okay, so now let me clean these things. So we have got theta I and theta r. Now what we need to do is, here first we need to find our perpendicular, which is nothing but sine square theta I minus theta r by sine square theta I plus theta r. Okay, that's how we used to obtain this. Then if you put the values of theta I and theta r, then here you're gonna get 16.9 and sine square 16.9, and here we're gonna have sine square, what we're gonna have, 73.1 degree. Okay, that's what we're gonna have here. Okay, if we use these two values of theta I and theta r. So now you see, again you have to draw this triangle. You have to make you have to take just make using the protractor, make the 16.9 angle. Okay, 16.9 angle, and make this hypotenuse 1 centimeter and draw a perpendicular. Then find the length of this perpendicular, then divide the perpendicular by the hypotenuse, then you're gonna get the value of sine 16.9. okay, if you measure this angle, if you take this angle 16.9, okay, then you're gonna get the corresponding sine 16.9 value. If you take the hypotenuse equal to 1 centimeter, it doesn't matter, you must it is not necessary that you should take 1 centimeter, you can take 2 centimeter as well. Then you have to draw the perpendicular, then measure the perpendicular. Okay, so perpendicular by hypotenuse, that's going to be equal to this, right? So if the angle is 16.9, so then whatever value you're gonna get, then square that one, then you're gonna get the value of sine square 16.9. okay, so that's how you can find this one as well. So here I have used the calculator, okay, instead of doing that, and we have after calculating all this square value and dividing, we have got 0.09337 approximately. And then you can find r parallel, that is equal to 10 square. Here again theta I minus theta 1, theta r by again 10 square, theta I minus plus theta r. That's what we can do. Now you see, again, in order to find the 10 square, 16.9 by 10 square, 73.1, you can use the same procedure that you have made this, and take the base 1 centimeter and draw an angle of 16.9. okay, then measure the perpendicular. This is base. We know 10 is equal to p by b, so then you're gonna get the corresponding value of 16.9, then square it. Similarly, you can find this one as well. So then what will be the value? Then you're gonna get approximately 0.00852. okay, just let me write here 0.00852. okay, so now this polarization, so we have got r perpendicular, that is 0.09337, and r parallel, and we have got r parallel, that is 0.00852. okay, now let me clean these things. okay, now what we can do, we can find a degree of polarization, which is given by r perpendicular minus r parallel divided by r perpendicular plus r parallel into 100%. okay, and if you put the values and calculate this, that's going to be approximately 83.3%. okay, so this is going to be the result. So hope you have understood this. Now next question is, here so set up cutoff frequencies for TM and TE modes of rectangular waveguide. So that should be different. okay, this is the correct option. okay, so these are the MCQ questions, and remaining questions will be solved in the next video. Thank you for watching. See you in the next video.